vector that is parallel or lies on that plane, and I can cross those two. So right here, this vector, -3, 1, -4, that is parallel to the plane. You guys agree with me?
Yeah.
Because it's parallel to the line, and the line is in the plane. So in a sense, it's parallel to the plane. So if I can find one more vector that's in that plane by doing like Jasmine said, finding 2 points and subtracting them, or some other way. And to me, it makes sense to find one more point and subtract them. I got the point 1, 1, 3. I got the point 1, -1, 2, right? Subtract and get another vector. So my one vector is this guy. We'll call him the U vector. All I need is one more vector, and we got that one. We can make it. It'll be here. Here's P. Here's Q. So the other vector will be PQ. And then you can cross those.
How'd you get U again? Vector U?
That was straight from the line, this vector here, right? Remember, the equation of a line is a point to start at. It's really a position vector for that point, plus a multiple of a vector in that direction. So there's a vector I can use. That's a vector in the direction of my plane in a way. It's parallel to a part of my plane. So I need one more vector that's parallel to a part of my plane somehow, and I can cross them and get what's tangent, or not tangent, but normal to my plane.
But how'd you get those specific numbers?
Oh, from here, -3, 1, -4. Just pulling a T out, right?
Oh, okay.
Broke this up into constant pieces, which are the point, and T pieces, which is the vector it's parallel to. Cool. So this is nowhere near as easy as finding the equation of a line in algebra, but you start to see how it's exactly the same process. You just have to have a little bit harder things to go through. I need two things, a point and not the slope anymore, but something similar to the slope, a direction. How do I normally get that direction? Well, I can cross two vectors, or I have to give it to me somehow, right? So that's the thought process you go through. How do I get two vectors that I can cross to get that normal? So what's this other vector going to be?
0, 2.
Yeah. 0 and then 2. Sure. Either way you want to go. -2, -1, or just 2, 1. You can subtract either direction. I don't know how I put it PQ specifically, but who cares? So if I did PQ, it would be -2, -1, yeah. So then you can cross those guys. And once you got that, you're done basically. You just got to throw it in the right place, right? So let's cross those vectors real quick. I get the opposite of what I got. So I use the 0, 2, 1. Are you getting, who's got something? What do you got?
-9, 3, and 6.
-9.
3, 6.
Should be -3, I think. Yep. Okay. Because remember, when you do that, if you do the shortcut, it's kind of built in. You have to subtract the second group of 3 that you do. If you do the J piece here, it'd be 3 minus 0 is 3, but then you have to minus it because that checkerboard plus minus plus minus. All right. But the shortcut kind of builds that in by subtracting that second diagonalization you do. And then, what's that? What the hell is that?
It's normal.
It's the normal vector. So what's this otherwise known as? What letters do we use? A, B, C. Oh, look. So this is A, this is B, this is C. So now I can just throw them into my plane equation. A times x minus x naught plus b times y minus y naught plus c times b minus z naught equals 0. X naught, y naught, z naught is any point that I know lies on that plane that I want to use, right? It shouldn't be mystical or magical to us that we can use any point, it's going to come out the same number at the end, right? Those coefficients kind of force that to happen. So that's not too bad, right? Plug negative 9, x minus, well, let's use that guy, plus minus 3, y minus 1, plus 6, z minus 3. And just get the constant out of there. Figure out what that constant is. Now, I will say this. The funny thing to me, some of you guys had a version of the quiz where you got a normal vector, negative 11, negative 11, negative 11. I did not force that to happen. In fact, I was just making stuff up, and I figured it's very unlikely you're going to get one like that. And you did. Really freaky. So some of you guys on number 2, it came out to be negative 11x minus 11y minus 11z equals 0. It was already through the origin. So my next question was very simple. The same damn thing I just got. It already goes through the origin. Right? So I didn't mean that to happen. I didn't make it happen. It somehow randomly happened, which I didn't expect. All right. How are we doing there? I desperately want you guys to see how it's exactly the same kind of problem as find the equation of a line was in algebra. It's exactly the same question. To get the parts involves harder processes sometimes, but it's the same idea. And the funny thing is number 4 looks more involved. Possibly, right? But number 4 is easier. Or at least the same. Yeah. They give you 2 lines, right? So you have 2 vectors already given to you, right? They both have the same point, but you only need 1 point, so who cares? So number 4 is actually easier. Yeah?
So in this problem, so basically that plane, the equation of the plane that you're looking for is intersecting that point, is that?
Well, the point lies on the plane.
Lies and it goes through that.
Yes, wherever the point is, it lies on that plane. And in fact, even more for this problem, an entire line they've described lies on that plane.
Along that. So that's why if we find those vectors, they're in that plane, so they're not sticking out.
Exactly, they have to lie in the plane. So the vector in the same direction as the line's got to be in the plane, because the line's in the plane, right?
Okay.
And the other vector was one I got between 2 points that I knew were in the plane. So that's got a line in the plane.
That makes sense.
Cool, 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 cool. My favorite phrase. That makes sense. All right. I want to show you an example of a really simple example of the directional derivative. And actually, not even directional, just gradient and what it's supposed to tell you. I've got to figure out how to approach this. Somebody tell me, what does that describe in 3-dimensional space? What does that describe?
Plane.
Beautiful. It's a plane. I love it. And what does it go through? All right. For one thing, it goes through the origin. I love it. Right? And let's look at it first in just the YZ plane. Can we graph it just in the YZ plane? Yeah, so give me some points to plot. 0, 0, I love it. 1, negative 1. Negative 1, 1. All right, so there it is. And in fact, that's at what angle with the z-axis, for example? 45-degree angle, right? Now, can you imagine? It's not that hard to go from a YZ plane to an XYZ system, right? Because the x would just kind of come out of here. So I don't really need to draw that, do I? Because we all know how ugly that gets. But the x is coming out of here. And what happens to this line when I extend it into 3 dimensions, like we just said? It's supposed to be a plane. So it's just a plane going like this, right? So which direction should I move to go up the fastest on that plane?
Same direction.
Which direction should I move in the XY plane? Which direction should I move to go up this plane the fastest? If I move on the x-axis, if I move in the x direction, am I not just staying level? Right? Aren't all, in fact, what letter's missing? So what are all the level curves parallel to? x-axis, right? So if I move in the x direction, I'm just going to stay on the same, I'm not going up anyway, I'm not going up at all. That's obviously not a very steep ascent, right? Shouldn't I go this way? Which means this way on the xy plane? So if I'm moving around in my input areas, so the domain is my xy plane. If I'm moving around that plane, which way should I move so that my outputs are going up the fastest? I should go this way. And what is this way?
-1.
Be more specific now. What's -1?
It's C.
What vector is this in 3 dimensions? It's not that hard. What's the unit vector pointing in this direction?
J.
I'm hopeful. What's x? Do I want to go x at all? Okay, so x is 0. What's z? All right, good. Y is -1 because I want to go back on the y-axis. And do I want to go up or down at all? I can't, right? In fact, let's just stick with 2 dimensions because that's really what I want to look at, just in the xy plane. So that's the way I should move in the xy plane. And in my head, I got this really silly thing about some dude walking on the ground, but he's got a balloon or a kite. And if he moves in this direction, the kite goes higher. If he moves in that direction, the kite goes lower. Of course, what gets weird is the kite burrows into the ground and it goes it's like, bam! It's so weird. But that's a decent visual because what's really weird is when I'm talking about the gradient, I'm moving on the xy plane. We're talking about how quickly the z values change, but all my stuff is related to the xy plane. So I'm moving on the xy plane. For my kite to go up fastest, I should move on the y-axis. What's the gradient of the equation associated with this? And what should my function look like so I can take a gradient of it? Who knows?
Well, it has to be into z as in
Okay, z equals
-y.
-y. So what's fx?
0.
0. What's fy?
-1.
All right, and so what's the gradient then?
0, -1.
And what did we say should be the direction that I move in for the steepest ascent? 0 frickin' -1, right? The gradient, what does it do? It points in the direction you move to make the z values go up the fastest. And I love this example because it's very simple. It's just a stupid ramp. So if I go in the x direction, if I go 1, 0, I'm just going on an even line on the ramp. I'm not going up or down. Not very interesting. But if I go this way, I'm going up the ramp the fastest I can. Every step I take gets me up faster than any other direction could. That's the whole point of a gradient. This is a very simple example. When it gets all curvy and shit, it's hard to keep track of the idea because you got all this direction and all this stuff going on. That's the basic idea. It points me in the direction I need to move to make my z values go up the highest. In which direction do I need to move to make them go down the quickest?
Opposite.
0, 1. Right? 0, 1. And of course that would make it go down the quickest. Okay, maybe. So I like that example. I came up with it this morning. So I like that. All right. Okay, so now I'm open to whatever you guys want to talk about or do. So you can do the quiz corrections if you want to. You can do some homework and ask questions from there. Yeah.
Can you do like an example for like graphing one of those crazy things and like doing traces and combining all of them?
Oh, okay. So like something from...
Unless you're not going to put one of those on the test.
On the test, what I'm going to do is sort of like I've done, and in fact, I'll tell you this, on the test, I'm going to have a problem like this.
Okay.
If you look on page 785. 785.
Everyone just starts shouting out their first.
I'm going to give you a computer-generated, thank God, image of a complete 3D graph, right? And try to have it oriented so you can access the easiest. I'm going to ask you to trace on top of that what you find. So it's going to be a little bit easier. In fact, I might give you 3 so you can put one trace in one place, another trace in another place. So what I'm saying is, on top of the image.
So you're not even going to give us the formula for?
No, I will.
Oh, you will.
And then from the formula you figure out, and then you can, but you know what it should be. I've already given you the end result. So you'll on top of this. So what should, like for an elliptic parabola, what should the xy trace, or let's just do this, an xy general curve, what should it look like? A contour curve. What shape should it have?
Circle.
On the xy plane.
There should be a
An ellipse, right? It's hard to tell from this, but that's not quite circular, right? But I'll take circles. But it's going to go around, and you just all you have to do then is just go around. So I might say for z equal to 3, put that on the image I give you, right? What I'm not going to do is what's really difficult to do, as we saw, and that's the reason why I didn't assign like a ton of these, is to actually put them together and give me a final product. Because we can't shade as well as a computer can. It's really difficult. I am definitely not artistic. I like to paint, but it's very impressionistic. Very impressionistic, right? Yeah. Any other specific things you want to look at right now, or?
What's that?
12-2, number 30.
30? No, 12-2. Oh, okay.
You're doing something else.
This one's kind of nice.
Just do it.
So graph several level curves of the following functions using a given window. Label these 2 level curves for these guys. You can do this in your calculator. You just have to develop the functions you have to graph, right? And how do you find level curves? What do you really do? Yeah, what's the range of this? What's the smallest z can be, or what can it approach?
Greater than 0.
Yeah, z's got to be greater than 0. It can't equal 0, right? Because we all know the exponential has an asymptote of 0. Okay, how many dimensions you plot in, right? And now you just put it down. Now you pick a z value. Pick a z value. 1. I love it. That's an awesome z value. So you got this. Now your whole problem is, in order to plug this in your calculator, what do you have to be able to do?
70.
Alright, you have to be able to solve for y, right? So if you take the natural log of both sides, what's the natural log of 1?
0.
And the natural log of e goes away. This is going to end up with a plus or minus, and I was a little disappointed. There's several people that had like y squared equals 2x, and that became y equals square root of 2x with no plus or minus there. You're losing the whole bottom half of your parabola if you do that, so be careful. So here, the same idea. What's going to happen here? Well, if we do this, it's negative. What's the only real solution to this? 0, 0. Cool. So on this one, for z equal to 1, my level curve is that point, like we were talking about earlier. So the only thing is the trivial solution 0, 0. So that means whatever it is, it kind of like starts at z equal to a height of 1, it's at 0, 0. What about z equal to 2 then? What are we going to get? Natural log of 2 equals negative x squared minus 2y squared. So I get 2y squared equals, what do I get? Natural log. Let me see. It's freaky as hell. this. Yeah, let me think.
It has to be less than 1.
It's just that name.
Yeah, it's got to be less than 1, right?
Yep. I'm not sure how to explain why.
Well, if you do like a generic thing that's bigger than 1, anything you want, it'll end up with natural log of something here bigger
So it's
than
going to be imaginary.
1. So no matter what, like if you just put a general like z naught there, you're going to get something. Yeah. So you want that natural log of something to come out negative itself. So it allows for something minus something, so I can actually do something. So if I do, for example, z equal to 1/2, what do I get? The natural log of 1/2 equals this. And actually, we can be kind of smart about this. We can do 1 over e. Why not? And what's the natural log of 1 over e?
-1.
-1. So I got 1 equals x squared plus 2y squared. Right? I don't think you really need the graphing calculator for this. I mean, what shape would that be? Ellipse, right? Since they have non-equal coefficients, right? So the next thing I would do is z equal to 1 over e squared. Right? So that it comes out nice. You don't have to. I mean, you can make these ugly since then you can put them in the calculator. If you wanted to put this in the calculator, you solve for y. Do you have to do plus or minus there, right? You do y1 equals a plus 1, y2 equals a negative 1. We've done that before to get both the top and the bottom of the circle. Right? Or an ellipse in this case. Okay, cool. Maybe.
Can I ask another question?
Sure.
It's 12.258. It requires consider.
I remember this one.
Sorry. They got a reaction out of the crowd.
What was that one?
Number 58?
Yeah.
From the same section?
12.2?
12.2.
This is the one you forgot to do.
Oh, cool.
This is the one you forgot to do.
Well,
When I was
I guess I did say consider.
Oh, yeah. So this is the one that I was desperately hoping you guys would go to Wolfram Alpha.
Oh,
If you go to Wolfram Alpha and plot this thing, it's really easy.
And then I
Yeah, who did that? Looks like a few of you guys did that. Anybody else do that? Go to Wolfram Alpha?
How do you
Let's do it.
that?
We'll do it.
You can't use that on a test.
No, you can't. So if you want to, I'll do it. If you want to focus on stuff that'll actually be on the test, then we can do that. But if you didn't try that problem, go to Wolfram Alpha and just tell it to plot that thing.
Yeah, I'll do it.
Yeah.
I had Chess do it.
Yeah.
Just have Chess do it. Chess
Like I said, I'll do it, but I'm not going to have that problem on the test.
No, don't worry.
If you want to focus on what's going to be on the test, you can do that.
Couldn't we just go ahead and take the derivative of this part, like the x, and find the minimum of that, which is going to be 1/2?
You can see where they come out of this, and actually now that we've gone further and done some partial derivative stuff, there's another way to do what they're doing. We haven't,
How do you get the maximum peaks?
so in our future, section 12a, if you've looked ahead, is the minimum maximum problem. And you guys remember in pre-calculus, you had minimum maximum problems. And they were basically parabolas, because that's all you could do then. Calculus, you had a lot of functions, because now min and max was just setting derivative equal to 0. Ooh. Right? Now we know how to do partial derivatives of stuff, so now we can do min and max problems with several variables, because now we know how partials work. So you actually, once you see the answer, you should be able to see kind of like where it comes from, and tease out, like you just said, how you can get that more directly. You're not allowed to do it here, because at this point we hadn't learned that yet. Right? But now that we've learned no more stuff, you can look back and go, oh, I could just do something like this, and that must be how it works in general, right?
Is that number?
Something like that.
Numbers?
I just went ahead and separated them and just like did it, because I knew if one of them 0, the other one would be 0, and I don't know why, I just took the derivative of that and derivative of that and solved it.
You gotta be careful now. I mean, doing it that way works with some nice functions, but not in general. Yeah. You kind of work backwards and see that that's a process that works for this problem, not in general. Yeah.
What number? What question was that?
58, right?
No.
Didn't you ask that?
The one you were talking about right now.
She asked. All she did was she took the pieces of the function.
Oh, it's the same problem.
Yeah.
Okay.
and this here, and she looked at the pieces to see, and for this one, what'd you do?
I just took the derivative, which is 2x minus 1.
And made it equal to 0.
0.
Because that would be sort of like what we would do if that was the only problem. We would take the derivative, take it equal to 0, and there would be a max or a
that's
min.
what I was thinking, yeah.
Okay?
And then I did the other, for that one.
And the reason it works for this is because it's separable. The x's can go all together, the y's can go all together, which is roughly similar to separable equations for all the people that did diffie Q. This is a nice equation because the x and y can be separated from each other, right? Okay.
15, 12.5, 16C.
Oh, real quick, let me ask you this, since we're talking about this. So whatever the hell this was, what would partial of h with respect to x be?
So x minus 1.
Yeah, because this whole thing here is
That's 0.
it's constant, so it's just gonna.
Oh, yeah, I'm sorry.
So what has to happen? You gotta be careful. So the derivative of this with respect to x is 2x minus 1,
That's multiplied.
and that just comes for the ride, right? Because that's a constant. And what's the partial of h with respect to y? Same idea. 2y plus 2, and that comes for the ride. Right?
The 2 comes to.
And then what maximizes this for x and what maximizes this for y? That process, you got to be careful, doesn't exactly work for everything just because this is a very nice function. It gets a little uglier when there's mixtures, when you can't separate them entirely. Yeah. But that idea actually, we build on top of that idea that do uglier functions. Okay, enough of that. So that one, they just want to look at the picture, right? And I was hoping that you guys would go to Wolfram Alpha, because you're totally allowed to go to that bad boy and plot some stuff in there, right? Any other specific questions?
12.5, 16C.
12.5, 16?
16 or
Part
16?
C.
Part C on 16.
16.
So they give me the pyramid. Oh, so let's do the, we got to kind of do all the parts of this. What kind of pyramid is it? Oh, just a. Assume that x and h are functions of t. Find the derivative v prime. So first off, help me out with that. How do we do that? What would it be in symbols?
Partial V,
Yeah,
partial X,
Yeah.
dx dt,
Good.
plus partial V, partial H,
Good.
dH dt.
I love it, right? Now if you come out of this with anything, that is what I desperately hope. How to write what they're asking for in symbols related to partials. I'm hoping we kind of all see how to do that. This has to be written as a partial because it's dependent on x and h, right? This one does not because it is actually only dependent on t in the end. X is only dependent on t, so it's not a partial. H is only dependent on t, so it's not a partial. So forth. Okay. Now you just got to fill in all the pieces parts. What is partial of v with respect to x?
2/3 xh.
Cool. And what's the partial of v with respect to h?
1/3 x squared.
Good. And dx dt and dh dt, I don't know. I'm just going to put x prime and h prime because they don't tell me what those functions are, right? So this will be, I don't think they tell me, do they?
Part B.
No, part B they do. Good. I like that. So this will be 2/3 xh x prime. How are we doing so far? Plus 1/3 x squared h prime, where prime is known to be derivative with respect to t. I like it. So in part B, they just tell me specifically what x and h are. They tell me x is t over t plus 1. And h is 1 over t plus 1. So now I just got to figure out the x prime and the h prime and throw it in there, right? So x prime h prime. Which one of these is not really a quotient rule?
It's a simple one.
Yeah, it's not, because the top is just 1. Okay, so it's just bring a negative 1 down, t plus 1 to the negative 2. So it's negative 1 over t plus 1 squared. And who learned the high, d, low, whatever?
Well, that one is t squared, t plus 1 squared.
I hate that.
I've never.
Personally, I just remember, quotient rule is exactly product rule. It just has something to a negative power, doesn't it? So of course, when I take the derivative of the bottom, that's the one that's got a minus sign, because the freaking bottom's to a negative power in reality, right? So it's top derivative times bottom, minus top times bottom derivative, because when I take the bottom derivative, it's a freaking negative on it. If you can't tell, I'm not too big into songs. And I'm bigger into like phrases, like King Henry died Monday drinking chocolate milk. Does anybody know what that is? King Henry died Monday drinking chocolate milk.
No.
Kilometer, hectometer, decameter, meter.
Are you kidding?
Yes.
That's worse than a song.
All right. Anyway. So what's x prime? Yeah, poem. Okay, I like it. That's what I always used to do. I always took the bottom up and made it to negative 1 power.
Minus t over t plus 1 all that squared.
Whole thing?
Well, just the bottom.
Yeah, the bottom. Okay. And when you put these together, you get what do you get? 1 over t plus 1 squared again, I think. T plus 1 minus t. Okay. How's that look? Okay. And then I just plug it in. So now for part B, this is going to become 2/3. X is this ugly thing. H is this ugly thing. X prime is this ugly thing. Too bad. Get all the ugly things. 1/3 x squared. H prime was this guy. Negative 1 over t plus 1. Good Lord. All right. So in the end, you're going to have like denominators on these things.
No, you're going to have to the fourth and the other one is to the third.
This is squared here, and this is squared there. And this will be 4th power here, so I think you will have. But you won't have the tops. One's t squared and one's t. All right. Anyway. So what do you get at the end here? You get 2t over 3t plus 1, 4, right? Plus, actually minus t squared over 3t plus 1, what the hell is that, Joe? T plus 1, 4.
I got the same thing.
I think, right? Now, part C is what you actually asked about. Of course, I had to get here to be able to answer part C. So this is part B here. That's what dv dt is in the situation they described. So part C says, is it increase or decrease as t increases? So really, that question is just exactly like, is it concave up or down? Is it, you have to look at your derivative that you did and then see, is it positive or negative?
So I just make it equal to 0 and find those.
No, let's see now. You get 2. These have similar, they have the same denominator, right?
Yeah.
And t starts at 0. T is greater than or equal to 0. So at 0, this is 0. Cool. At 1, this is 2 minus 1. That's 1. At 2, this is 4 minus 4. It's 0 again. At 3, it's 6 minus 9. It's negative. And it's going to be negative forever after that, right? So at some point, it's this derivative starts to be negative. So once you get past a certain point, it should be decreasing as t increases. Yeah. So in reality, let me make sure you guys are with me on this. So it looks to be about from 0 to 2. Because at 0 it's 0, at 2 it's 0. Let me do it like this then. In between there, it's positive. You guys with me? Because at 1, it's 2 minus 1, and it's positive. Bottom's always positive. Cool? So a fourth power. Above 2, it's going to be negative. So above 2, it's going to be decreasing as t increases. So the official answer to this question is neither, because in some areas it's positive, in some areas it's negative. Right?
As t increases, it's going to be negative. Though.
Yeah, but t starts at 0. So can you give you one answer to this question? No. If t was greater than 2, then it's always negative. And if you said that, I would take it. Because I would expect to be thinking about bigger than 2, maybe, letting it grow forever.
Yeah.
Then overall, it's negative.
I see.
Sort of like if you remember the beautiful series that everybody loves in Calc 2. Who cares what happens at the beginning? At some point, if it does the same thing forever after, that's what I kind of pay attention to, right? You can say something like that here, but officially it's both, depending on where you are. Okay, maybe. Okay. Any other specific questions? Or yeah. Oh, cool. So this one is about path of steepest descent. 12,646. And they give me this. This looks a lot like the problem we did earlier. So this problem here, right? Huh? Okay. So A says find this. All right, so do that. What's the gradient?
1, 1.
Yeah. I like that, right? Fx is 1, Fy is 1.
Time for that.
Yeah, that's awesome.
Cool.
Okay. So in the xy plane then, I mean you can go ahead and draw this. In the xy plane, which direction do you go to have the steepest? In this case, this would be the steepest what?
Steepest increase, high. I mean,
Steepest ascent, right?
Yeah.
And they're asking for the steepest
Descent.
descent. So if I go in the direction of 1, 1, that's the steepest ascent. And they want the steepest, it's just fun to say ascent, steepest descent. What's the direction of steepest descent?
Negative 1, negative 1.
Negative 1, negative 1. I like it. Cool. Now, the hard part about this is part B, right? So part A is pretty straightforward. It's just the negative of the gradient, because I want the steepest descent. I got to be facing the other direction then. Part B says, let C prime be the path of steepest descent on the surface, beginning at P. And let C be the projection of C prime on the xy plane. They make it sound very difficult, when actually I'm already in the xy plane when I have just my gradient, or my negative gradient there, right? I'm already in the xy plane. So, if I'm at the point 2, 2, 4, let me see, what's the best way to do this? Actually, the best way to do this would be, what would the, let me think, it's a nice way to do this. Let me try to do this. So I'm at the point 2, 2, this is always fun, 4. 2, 2, 4. Like right there. And I'm want to point in the direction of -1, -1. So -1, let me see here. -1, -1 would be this way, so I want to go this way. Alright. See you guys are with me. So I'm facing in the direction -1, -1. Right, so the 45-degree angle back there. There's my point on the plane. Right, 2, 2, 4. What they really want me to do is to find the projection of, so here I am on the plane, whatever this thing looks like, it's going to be going down the quickest if I move in this direction. So all my outputs are going to be going down the quickest if I put inputs in going this way. Okay, you guys kind of with me? If I follow this direction, my outputs for the points I put in are going to be going down the quickest. That's the whole idea. What they want me to do is find the equation of the line here. That's a projection of this point. Well, that's not too bad. What's the projection of the point into the xy plane? 2, 2. Is that cool? I'm just projecting the point onto the xy plane. I've got a slope, really, right, from my 1, 1 vector. Maybe. So my -1, negative, sorry. So -1, -1, so it'll be like, here's -1, -1. I'll going to be pointing in this direction. So what's my slope?
Why?
-1.
-1. I like it. Cool, right? My slope is -1. Right? And my point is 2. So I got a slope of -1. I got a point 2, 2. Can you give me the line equation for that? Yeah. Now I think if I remember correctly, I mean to do this it would be y minus y1.
Or you can just plug it into y intercept.
Yeah.
Yeah.
I know, but I want to make a point here.
Okay.
Equals m times x minus x1. And x1 will be 2. But let me see here. So this is like 1 times y minus 2 plus 1 times x minus 2 equals 0. Right? And what is this? And it's a little hard to tell. It's freaking 1, but isn't that's fy? Isn't it? And this is fx, isn't it? That's where we got the gradient from, right? And in fact, in part of the reading in the chapter, they talk about an extension of this form from algebra. Why is there only one slope in here? Because we only had one slope to worry about. When I extended 3 dimensions, now I've got more than one slope to worry about. I got the x direction slope and the y direction slope to worry about. So it actually just takes this form and extends it to have a place for both of those slopes to show up. And I think it's on page, did you have to know all that to do the problem? No. But it's on page 837 at the top. They talk about tangent lines, but I could actually use that to help me get this kind of answer. But did I have to know any of that crap? No. We just very directly, I want to go -1 slope, and I want to start at the projection 2, 2. And that's how I get my line. Is that cool?
So we need an equation of the line in 2 dimensions.
The equation of line, projection in the xy plane, yeah. So just 2 dimensions. Cool. Okay. This idea, though, I didn't want to talk about it in this section because we don't really need it yet. But in the next section, we're actually going to talk about the extension of this more directly. What does this function look? What does this process look like for us now in 3 dimensions? Okay. Let me see. Any other questions from homework? So you guys, if you could have quiz corrections to work on, whatever you want to do right now. Yep.
It's not a homework, it's practice test. Number 5, when we do domains. So my domain is always one dimension lower. So let's say for 5, my domain is R3,
Good.
right? Or it's R4, because it's a 4 dimension.
For a 3-dimensional function, My domain, like if I had a shape up here, what's the domain of that guy? Where does that domain live? What are my outputs for that guy? What letter? Well, my outputs are z. My inputs are x and y. So my inputs are r squared. They live in r squared. And my outputs are the z part. So the total surface lives in r cubed. So just like we already know this. How many dimensions does that line live in? How many dimensions do the inputs live in? We already know that it's one less. My inputs here are x, my outputs are y, but the line itself lives in 2 dimensions, right? Because it can move x and y. But my inputs are all on the x-axis, right? So here my inputs are all on the xy plane, and my outputs are all somewhere above or below it, right? Here, let me go ahead and give you guys the answer key. Oh, yeah. Anybody else not get their quiz back yet? Sanaa, you didn't get your something else back yet either.
Yes.
Yes. Did I give credit for the equation? Yes.
Yeah, like defining the equation for example of x, y.
The equation, yeah, I gave points. It was like 9 points each. Sanaa, did you get back your test? The last test? I know I got it somewhere. What's
Yo, have you heard this? Yeah. Lonely. Elf Machines, yeah. Elf Machines is the last song. It's like 2 minutes long, and then there's like a 3-minute space, and then they have like
Oh, I see.
Because this is like, I should have got one of this.
Oh, and then you needed more room or something. Okay. All right, let me because I thought it was because you're probably copying somebody else, but no, you had this one, you needed more room. I got it. Anybody else? No problem. When you do the correction? Okay, just right now the correction, see the notes, right?
Okay, I just want to make sure it's
Oh, okay. Yeah, I turned mine in late.
I wish
No, I just did the homework then. Okay, I don't even have to miss my class. You staying here? You staying
Excuse me.
I don't want to turn it off. That's the idea of contour curves are like, you have the shape that you show. So one level curve, but then when you take the unit vector, level curves projection. Because that's like 1x plus 2b, and then that's the vector right here. That technically. And so yeah,
I was either gonna wear this one, remember my pink that goes like that, and kind of put the flowers on it and stuff. But either that one or this one. The other one, like, I've never traveled boobs are very big, so I just I was like, man, I'm gonna be too big, and then I'm gonna have to like that. So I just but it used to be yesterday for my I'm really into just having the same class I can't draw my head because I'm just before they get to
equals 2.
Put on me. It's like,
X equals 0, Z equals 1, Z equals 3. Yeah. So if you put Z equals 0 in there, you get the point. Is that
My dad
y squared plus x squared over 4 equals 0. Only 0, 0
My brother
works,
was
and that's Z equals 0
4'6'5",
is there.
but
Z equals 1 would be
now he's short of me.
there. 4 is like y squared plus x squared.
What is he both?
So 1 equals y squared over 4 plus x squared over 16.
It's ridiculous.
There's just an amazing
I guess you win something.
He's scary.
And I would suggest actually do z equal 1 4 and a half. That'll actually make it easy.
I don't see.
Because z equal 1 4 I get a nice 1 there.
Maybe I should start looking later.
Indeterminate. It's all
Some
equal
people
to
go
0.
with
0 divided by anything divided by 0 is undefined. 0 divided by anything is 0.
I don't have that going.
So 0 divided by 0 is indeterminate.
Mine, you don't have.
It all depends on which one goes to 0 first. If they go to 0 at the same pace, that's when the limit could exist. That's the formula about limits of lower time.